This is a video podcast from the Canadian Centre for Architecture. The following is the first of 3 parts of the CCA's Urgency event held in June 2008 with Greg Lynn and Yang Ho Chang. It is the 2nd annual presentation of Urgency after the 2007 event with Rem Koolhaus and Peter Eisenman.
So, welcome everyone. As you know, this is the 2nd urgency event, and last year we hosted here Rem Koolhaus and Peter Eisenman with a very interesting conversation with Phyllis Lambert. And this year we are going to continue this kind of event. This event is reflecting a kind of ongoing exploration of CCA on critical issues facing architecture in general and contemporary society. Who are the guests that we invited this year to continue our conversation? 2 very important international figures, and Greg Lynn and Chang Yang Ho. This is the Chinese way to present. I always called him Yang Ho, and he told me, well, the Chinese way is exactly the opposite. But he accepts that we can call him Yang Ho in Western way, so from now on he will be Yang Ho. And the format of today's presentation is very simple. I'll start to introduce you Greg Lynn. He will do a short presentation. The question that we ask both of them is, what is which kind of urgency do you feel today for architecture to respond to? And second intervention will be Yang Ho, and there will be a conversation and there will be some questions, also from the audience. If you have a question in French, we can translate into English. Greg Lynn is now practicing in Venice, in California, since 1992. He has a degree in philosophy and in environmental design. I just summarize the place where he has been from the master in Princeton, and then he has been teaching all over the world, in the United States, Yale, he's now at the USLA, Vienna, Zurich, ETH Zurich. He has published a lot of very interesting books, which are of development, not only a presentation of his work, but also his thinking on architecture. Perhaps is not necessary to remind you that Greg Lynn is associated to the idea of blob. That is a concept that he has introduced, and he has developed in all his work in a lot of very interesting directions. And Greg is going now to present his point to you now. So join me to welcome Greg Lynn. Thank you very much.
Well, thanks for having me. Last night was really a lot of fun. A lecture in the garden is even better. I thought before talking about what's urgent for architecture to address, that it's maybe more critical to talk about what's urgent for architecture to think about for itself. And I think now we live in a time where there's a lot of need for building, And I don't want to say there's an inverse relationship between building and architecture, but it's maybe not the strongest time for institutions and publications and people to think about architecture. So before talking about what architecture should urgently be fixing, I thought it's maybe more critical to just remind everybody what architecture is first. And I just know that because I also get very distracted sometimes, and I'll show you some of that distraction. But so for me, and I'll go through some urgent problems. So the problem architecture's been working on for maybe 2,000 years, which is unique to architecture, is that we deal with large assemblies of components. And I think unlike industrial design or sculpture or any number of art and design disciplines, architecture is unique in the fact that we celebrate the fact that we make things that are whole out of a lot of parts. And the part-to-whole relationship is something that we specialize in. Now, I'll show you a lot of instances where the world right now is needing more and more architects. I talk to car companies and they say, soon we're going to need car architects because every car is going to be different and you're going to need to go talk to a car architect before you buy your car. You know, the number and quantity of design objects and decisions in the world is exponentially increasing, and the expertise of architecture is becoming more and more relevant all the time. But so I think what's unique about our field is that we deal with this part and whole relationship. I think the second thing is maybe unfortunate, and that's that people experience architecture as ambiance or atmosphere or environment. So people don't really pay attention to architecture the way they would pay attention to a chair. The quality of an object which is built out of parts could be celebrated for the fact that it's fragmented, but I'm of a generation that reacted against fragmentation. So I know when I was a graduate student, things like harmony, symmetry, proportion, holism, these were all really bad words. So I was, of course, gravitating towards them. And have always been interested in how you can make a thing which is whole, but out of pieces and parts. And the fact that the pieces and parts can all be unique or all be different is something that I'll talk about in a minute. But so, for me, I think one of the things that's urgent to think about is that a lot of things that we weren't supposed to be doing, again, like symmetry, is suddenly exciting and new again. And I'll show you some of the examples of what I mean when I say that old things are becoming new again. I'm involved in a project for a cultural island in Abu Dhabi. I have a very small piece of a very large development there. There's a series of 4 major museums from the Louvre and the Guggenheim, Maritime Museum, and a Performing Arts Center that are being done by Nouvelle, Gehry, Ando, and Hadid, respectively. And there are 19 art pavilions around it. And I think context is something that we'll talk about in a discussion probably later, but for me to find a context on an artificial island in Abu Dhabi with a client who was importing art and architecture, it was something that I really wanted to get some traction with. So the context for me was both the historic context of the region, like these Iranian bathhouses and vaults that I've always liked so much. It was also dealing with the context of the desert environment, where you can see the towers that are used there to superheat air and pull cool air through the building and out these solar chimneys. So for this project, which is very early in the planning stages, we were given a double pavilion that crossed a canal, an artificial canal that's being built. And just to the south of us is the Ando Maritime Museum that you see drawn in there, and next to that is Zaha's Performing Arts Center. So the brief for this was fairly open and was defined by Tom Krenz, And the brief was to make a subdivisible space which could be used for single artist shows 4 times a year, roughly 50,000 square feet of exhibition space. So I went back and looked at these Iranian vaults and how the domes are connected together, came up with a strategy for the ceiling where we could have one single gallery space that could be divided into 23 different gallery spaces by simply building temporary partition walls. And the center of that gallery space is what we call the bridge gallery, which is glass, and it's connected to a series of glass chimneys so that in the hottest part of the summer, these glass chimneys will heat up to about 150 degrees, whereas the long horizontal glass bars, which are next to the water, are going to take the cool air from the water, suck it through the building along their length, and pull it out these solar chimneys. And this whole complex is designed to, as it moves from the ground level to these oculi and to these chimneys, to get finer and finer in the scale and material and smoother in its surfaces. The second kind of issue, I think, for architecture to think about now is its convergence with other design disciplines. Not probably since the 1940s or 50s has architecture been so much like so many other design fields. So transportation design, industrial design, graphic design, motion picture design, aerospace, naval architecture, all of these fields are using exactly the same medium that architects are using. We're all using the same software. We're all using a lot of the same manufacturing. It's a time in history where architecture with other design fields are very closely aligned. And I think the audience for architecture is also interested in architecture in the same way it might be interested in the special effects of a film, let's say. So it's an opportunity for architecture to step into the popular cultural realm in a way it hasn't been able to. Also, you know, sooner or later in the United States, there's this war that's going to have to end. And I know in Southern California, where I work, there are things I can't do anymore that I could do 4 or 5 years ago. I used to be able to work with titanium, and now I call the titanium manufacturers and they say, we're busy building bombs and we're busy building planes. And the number of times that I call manufacturers and they tell me they're busy with the military, it's depressing. The optimistic side of that is they always tell me our capacity has doubled or tripled or quadrupled. They tell me they've got all kinds of new materials and new methods of manufacturing that they wished they could show me. And they say, look, when the war's over, we're going to have absolutely nothing to do, and all of this is going to be paid for, and we're going to be looking for applications, and we promise we're going to call you because we're going to want to start doing things like coffee pots and buildings and bicycles and cars and things like that. So I personally believe in the next few years you're going to see a precipitation of technology that even exceeds what happened after World War II. Because I know in my neighborhood, they're spending something like $6 to $8 billion a month on high technology, and nobody's going to know what to do with this stuff when the war's over. So there's a lot of convergence and opportunities for architecture to think about this. For me, there's the 300-year-old urgent project, which is using calculus in architecture. Different fields have used calculus. I think it's very recently that architecture uses it, and it has a lot of impact on the way things get put together. So this is just a set of dishes and plates we're doing, but it's just like what I showed you in Abu Dhabi in terms of its design technology. It's about putting different things together to make a whole out of something, which is made out of parts, while still having every one of the parts be different. So it's a non-modular way of construction, and it's about integrating things through surfaces. So for this interior that we did in Sweden, we had to do a flexible shelving system, and the points for support of the shelves were integrated into the surface continuously. Now, this, for me, is my approach to a kind of minimalism, where instead of having 10 different things get put together, you try to do more things with surfaces and more things with one piece. The first time I ever played with this is with this case design for Visionaire that we did with Hedi Slimane. It was very funny because a friend of mine put us together, ironically. And I got on the telephone with Hedi Slimane, and he said, look, I'm really looking forward to collaborating with you, love your work. There's just a few things I want you to do. The case for the magazine has to be cool gray number 3. It has to be a block of the following dimensions, and it can't have any visible hinges or latches on it. But other than that, express yourself. And so what I did is made the interior of this thing not only be where all the expression was, but also where all the work got done. So instead of having hinges and instead of having a clasp, it has these kind of teeth, and the case bites together, so there's only one way it fits, and there's only one way to take it apart. So we were able to make it without any mechanical hardware or hinges, all just by changing the orientation of the surfaces. Similarly, we did this coffee cup with Alberto Alessi. And Alberto said, I want you to do a coffee cup, but you have to put a handle on it, because architects never put handles on their cups, and everybody always burns themselves on the architect's cups. So I designed this cup so that it has thousands of handles on it, so that it's a volume on the interior with a hollow space with a shell on the outside. So you can always grab it without burning your hand, and it really works with the ergonomics of your hand. It also works so you can put it together, like only an architect would do this, but on 2 opposing sides, they always nest together like they're spooning together. So you can make arrangements on your tabletop and all kinds of different patterns when you put them together on the shelf. Same thing with this chair for Vitra called the ravioli chair. There have been chairs which eliminate the seat and the back and the arms by making a single bucket. But this chair is knitted with a 3-dimensional knitting machine that can knit contours. So the top is knitted, and then the bottom, instead of having legs, is also built out of one surface. So its expression is really just 2 surfaces, a soft surface on the top and a hard surface on the bottom. And we do all the work of a chair with 2 pieces. And in fur. One of the ways architecture can step into other fields like this is that because we design a whole and parts, it's possible for us to do things where we can design the whole group all at the same time. The same way we would design a curtain wall, where every piece of the curtain wall might be different, but it all belongs to the same surface, we can do the same thing with products. So for me, it's about starting with a primitive or a generic piece. Generic just means something that's yet to be specified. So this is another Alessi product. And when I met with Alberto this time, he said, I want you to design flatware for the table, but all you need to do is come with a spoon, and if you give us a spoon, we'll design everything else. He said that's how he did it with Castiglione, that's how Huffman did it, that's how Wright did it. Just design the spoon, we take care of the rest. And I said, you know, Alberto, I thought you understood me and loved me and knew me. I said, you have no idea how I work for you to say something that offensive to me. I said, you have to give me what I need to do. I want to design it all at once. And he said, that's impossible. And so I took that as a kind of challenge. And we designed a generic piece of cutlery which had everything we needed to make all the parts. And so this is the first kind of sketch. But I knew that we needed to have something like a cup for a spoon, or a blade for a knife, or the tines for a fork. And so out of that primitive, we started to play around and see if we could get this primitive to do different things, like make spoons and knives and forks. And we started to just run through variations. Now, as we did that, I was sending people in my office out to go buy books on the history of cutlery. So we were reading Emily Post and all kinds of information about cutlery to find out what the variations would mean. And eventually we came up with these 52 pieces. These are renderings of the first ones, and then 3D prints that we made in my office, and then finally the finished cutlery. And now I'm an expert. So, you know, we did oyster forks and pickle forks and, you know, fish serving forks. The wide one is a cream chip beef fork. You know, dessert spoons that are slotted, and serving utensils and ladles, and all the elements we needed. They all, if you're someone that knows the history of flatware, you'd actually identify the functions of all these. But what's important is there's no one that we started with. So there's no best one, which was really what I wanted to avoid with Alberto, was the idea that there would be this ideal spoon and everything would be a derivation of that. You know, here all 52 are unique, and all 52 have their own function, and they really work like a family. You know, like, I love everyone equally, but no one is better than any of the others. They're like my kids. So, something else that I just found in this is this quality of near symmetry that I thought I'd share with you. It turns out that we, as in the human race, don't find people beautiful that are symmetrical. What we find beautiful, that you can see in this diagram, is someone whose nose and or lips are 10% asymmetrical from their eyes. And if you have like a funny looking friend, I would suggest look at the funny looking friend. You'll find out they're more symmetrical than they ought to be. So for me, symmetry has become a kind of like a powerful tool for both organizing things, but also a powerful tool for breaking symmetry and bringing things close to symmetry in terms of both beauty and function. This was the very first sketch model we did for a housing complex in Spain that we're working on right now, and it's changed significantly, but what you can see is it has this quality of near symmetry, where we have 28 units. They're more or less identical. They're all the same in how they're organized, but every one is a little bit different. These were the very first plans we started with. And how it's evolved is the void spaces between the units all have this quality of near symmetry. This is a typical plan of one of the 6 floors. You can see there are these void spaces between apartment units. This is a model of the different floors. And because of the budget in Spain, we've rationalized these so that we can build it all out of one of 4 super components. So basically each unit has its own facade element, and we can rotate it and align it. So out of those 4 units, we can always get a thing which is nearly symmetrical. Everything was going really well in the drawings until I saw this rendering and got nervous. Then we built this model, and it went very Flintstones or something on me with the punched windows. And so what we did, my wife Sylvia Lavin was working on discotheques in the 70s in Italy. And I said, well, why don't we make the facade a disco ball? And the first thing is we covered it all in chrome. It looked just as bad. It was just shiny. And then I said, well, why don't we do the disco ball physically, in the sense that we know this is a photograph of a mirrored ball, but what if we thought of it at the scale of architecture, where it was built out of 6 different colored panels? So for the facade, we're building it in 6 different colors of aluminum, and this model is built in 6 different colors of aluminum. So if you look closely, you'll see there's gold anodized, bronze anodized, black anodized, white painted, polished, and brushed aluminum. So there's 6 different colors of panel, plus the mirrored glass. So by using those 6 different materials to render the building as if it's shaded, we could get rid of the effect of the punched windows. And here you can see in kind of coded form how we do the 6 different colors on the facade. The next thing I'll talk about a little bit is special effects. This is a planet I designed for a film called Divide that's coming out soon. They called me up and they said, look, we need an architect to design 4 planets for our film. So we designed these planets. We just finished an exhibition for Paolo Antonelli at MoMA where we designed an online city for 8 billion addresses. So everybody in the world gets an address in this city. And every city that exists is located on one of these 6 continents. And the continents all move through each other in a line so that every time you log into this, it's a little bit different. These are the first attempts at giving these things urban and architectural scale. This is a media project we did for Herbert Mouchamp in Monaco at the Grimaldi Forum, where we used weather balloons as projection screens, and we synced up 12 of these screens all together to make a single image or to make individual images. And all these projects I just showed you, we worked with a company in Los Angeles called Imaginary Forces that does film titles. So for me then to take this research with a film company and bring it into architecture, I tried to solve this decorated shed paradigm in a little bit different way. This is a restaurant that we're just in design development right now with it. It's across the street from the Los Angeles County Museum of Art, and it sits in front of an existing skyscraper. And it's not a very large restaurant, but most of its seating is outdoors. And it makes a new gateway to this existing tower right across the street from the Renzo Piano building. So what we did is we aligned, and you can see how it sits on the corner, and then it has a roof that extends all the way to the edge, the opposite edge of the existing tower. So the way we designed the roof was so that in December, the sun passes right through this trellis between 12 and 1:30, so you can sit outside in the sun at the coldest, darkest part of the year. And then in June, the orientation of the grid plus the depth of it makes it shady also between 12 and 1:30 in June. So the grid gives you shade through the year, but at nighttime the grid becomes a kind of media device. So there are roughly 144 pixels, each one of those 4-foot by 4-foot bays. And Imaginary Forces has designed a series of film contents that play on the roof of the building at night. So when you drive by at 40 miles an hour, you see this subtle shimmering movement happening in the roof. It's not like a discotheque, and it's not a sign. It's not going to give you a seizure when you sit under it. So it moves slow enough that it's not annoying, but it moves fast enough that you can see it when you drive by and see that there's actually movement there. So this kind of integration of media into the building is something that has come out of this collaboration back and forth between the film industry and architecture. I thought I'd show some things that are really about my love of popular culture. Not that I don't love high culture, but I really love popular culture. The first is a series of plastic experiments, let's say. We did these lights, this ceiling for the ICA in Philadelphia we cut the molds for them in my office and made them in fiberglass with a surfboard manufacturer down the street from me. And it got me thinking about how to use translucent fiberglass. I also happen to, my secret desire in life is to build a high-performance sailboat. And so I figured out a way to build a sailboat on the ceiling of a client's house without actually telling the client I was building a sailboat in the ceiling. So this is a house in Los Angeles that's just about done. The ground floor of it is a single room, but all of the subdivisions of it happen by folding and curving the walls. And then upstairs, it's a series of rooms, but they all share one party wall, which is curved to take care of equipment and furniture. Then hanging from the ceiling of the ground floor is this 8-foot deep and 50-foot long boat in translucent fiberglass, which lights the whole house at night. The windows of the house, it's a very tight site, like a party wall site, but the windows are all also cut with curves. And what's probably interesting about the house is that we've used a lot of new materials and new approaches, but none of the machines that we're using are younger than 30 years old. And I think a lot of people assume that the construction industry has to catch up with the designers, but it's absolutely the reverse. The construction industry is an industry. So everything's been industrialized for almost 100 years, and it's the designers that don't know how to use the stuff. So these windows are all stock windows from Pella in terms of how they're manufactured. We just approached them in a new way. You know, the tops of these would be called cathedral windows that everybody uses in their suburban houses. We just flipped the tops over so we could make this new kind of a shape. Same thing with the, there's the boat. Same thing with the interior. The ceiling is all made in resin that we CNC cut up in Sonoma County. The manufacturer for this is a guy that used to manufacture J-80 boats. He covers these molds with foil and forms all of the components for them. This is the setup of the components before they all got shipped down to Los Angeles. And then we actually used for the lighting a type of lighting called cold cathode lighting, which was invented before the fluorescent bulb. And the only difference between it and a fluorescent light is it has no ballast, so it lasts for 30 years and is dimmable and uses less energy. But obviously the light companies didn't like any of those things, so we buy fluorescent fixtures. But it has a 40-foot long cold cathode fixture in it. Yeah, you can see there. In addition to the fiberglass, there's a lot of other plastics in the house. These are curved walls that are in plaster, which I'll show you in a minute. But the bathrooms and kitchen are all formed in corian, which is a plastic kind of material with properties like stone. And you can see for the bathrooms, we cast the sinks, the cabinets, the drawers, the mirrors, everything all into this monolithic corian surface. And just for architects to think more entrepreneurially, you know, we developed this with DuPont, and DuPont owns the patent on how to form it, and I'm marketing these things now as products. So, you know, we got paid our ridiculously low fee for the house, but now these elements get sold like furniture. This is a tile wall, which is all computer-placed tiles that are a rendering of the wall on the opposite side. So even all the 2D surfaces have computer-placed tiles. And then similarly in the kitchen, all the tables and work islands and things like that are made with this corian. The beds, the lighting we're doing with stereolithography lighting. The interior framing of the house is all done with laser cut plywood. And again, this machine's 30 years old, so it took 30 years for somebody to think to just ask. This is the contractor looking at the pieces. And also we use less waste with this than if we use stud walls, because we're not cutting off all this scrap, we're nesting it all very tightly and maximizing the use. So the other funny thing is, this got shipped to the site and the job manager said, "Don't you dare touch this stuff, it's all numbered." And the contractor, the guy that owns the firm, called me at lunch and he said, "Everybody's gone, let's go put it together." And the owner of the contracting firm, myself, and a woman that works for me put together this wall in 45 minutes. So the house has like no unskilled labor of people whacking things with hammers. It's all either precision cut computer elements or precision 19th century plastering going on in the house. Okay, then I'll show you one more, actually kind of 1.5 more plastic things, then stop. So the other plastic project is I wanted to redesign a brick. Like I wanted to make a plastic brick. And it's become this thing we're calling the blob wall, where I designed a customized hollow plastic brick that's about 1 meter rectangular and a ½ meter deep. And it's designed so that it can go kind of nose to crotch, always fit together to bond to make walls. But unlike a normal brick, there's no mortar used in this. So there's no artisanal craftsmanship in it. Instead, what we do is we stack these bricks up in a computer, we find their intersections, we take the line of the intersection and program that as a toolpath to a robot, and the robot cuts those pieces, then we chop it up and melt it and use it for another brick. So, which also lets us get a lot of color variation in it. But so this is the brick, or this is one of the bricks being cut by the robot. And this is some stages of how we assemble these brick walls. And you can see every brick is the same in the sense they're all modular, but once we've cut them with the robot, they're always a little bit different. There's only one way for them to go together. So we've done about 10 of these things. And the largest one we just did in the gallery at SciArc, which we did as a kind of big freestanding pavilion. They're very lightweight. They're very transportable. 4 or 5 people can pick this whole thing up and walk around with it. And even students can put it together. This is us driving one of them around all my favorite monuments in Los Angeles. So we use them. They're also great for putting outdoors and using in gardens and pool cabanas and that kind of thing. It started from an idea I had for recycling all my kids' toys. And this is something we're doing now for the Venice Biennale, which is recycled toys, where we've been collecting all these toys for the last year. Again, all the same way we made our bricks are the way these are made. We take these things and run them through a computer scanner, which gives us an accurate 3D file for all the different toys. We then put those toys into a computer and compose them into things like this bench, like tables, a shelving wall system, and a shoe closet. So all these freestanding interior elements. And we take the toys and put them on the robot and cut them apart and weld them together in exactly the same way we do the blob wall. So we're also doing these kind of recycling plastics. Last thing I'll show you just real quick is where all this stuff came from, which is the house that, God knows when we're going to finish designing it and pull the trigger on it, but this is a house for myself and my wife. I was kind of inspired by the Lina Bobardi house, which has a courtyard on a hill punched through the middle of the house. And so we wanted to do a house that had these floating punched courtyards. It's a very difficult site we've got, which is this triangular site. And so what I did as a start was work with Klaus Bollinger and invent this funny truss made out of one continuous rolled tube of steel that gets expressed on the outside of the house rather than on the inside. So it's not a square rectangular section like this, it's a round 8-inch tubular section. And this is on the Gary Technologies software. You see how it works. The sections are always tangent with each other, and they always intersect each other and get welded so you can make a rigid truss out of a single curvilinear tube. So turns out it's incredibly strong, stronger actually than a Varendeel truss, and it doesn't have columns and beams. It has one woven tube for each side of the house, which you can see there. Then these tubes get lofted together like this in plan to make the courtyards that cut through the upper level. So it goes kind of bedroom, void, bedroom, void, bedroom, void. So between each room upstairs, there's always a little courtyard. Then on the north side, we'll glaze it so you can see the structure floating behind the glazing. Something like that. That facade's going to change. These are those voids cut through the house. And also, if you see lurking in there the kind of lumpy red plastic thing, this was the first place I had the idea for the blob wall, because my wife loves plastics, and the structure's so expensive, I needed a cheap way to make interior walls. So, thanks.
This was a video podcast from the Canadian Centre for Architecture. For more information about this and other CCA programs and events, please visit www.cca.qc.ca.